Welcome back, part two of the skeletal system, part one. So yeah, chapter six of the skeletal system, second and last half of these short notes. So we left off with the osteon. Remember, the osteon is the basic unit of structure compact bone. Here we see three osteon, or two and a half. So you get the central canal right down the middle, which brings the blood vessels up. You get your little thin black holes they live in called the lacuna matata. Osteoblasts live in the lacuna. The osteocytes, the osteoblasts put the bone on when they're trapped. Now they become osteocytes. So osteoblasts become osteocytes, and they maintain the cell. And more lamellae, or these rings of hydroxyapatite, rings of hard mineral, are put down. Again, it's called extracellular matrix because it's put around the cell. It's matrix, means just stuff. And this happens to be hard stuff called hydroxyapatite, calcium phosphate crystals. So the osteon, again, makes up compact bone. There's an osteon. So it's a whole unit. They blow it up, and now you can see the central canal, these little perforating canals, which allow blood vessels to come across. Got your little canaliculi, the little cracks, which allow the blood to seep out to every lacuna to feed the osteocyte in the lacuna. And 11, of course, is the osteocyte. Rings of lamella. Lamella, again, think of laminate. When you laminate something, you're putting a sheet of plastic on top of it. In this case, you're putting a sheet of bone around the central blood vessel, kind of like tree rings. So here's some practice for you. You can look down there, you can see the osteon sticking out. Those arrows are tough to point out. That arrow up there is pointing at the lacuna. I don't know if you can see my little arrow pointer. This whole thing over here is the osteon, of course. This double arrow is pointing at the central canal. So thin sheets of extracellular matrix are called lamella. Lamellae. Lamellae is plural, lamella singular. So the periosteum again is the fibrous connective tissue surrounding the bone, which contains osteoblasts and osteocytes. Osteoclasts, sorry. So clasts are constantly chewing away, the osteoblasts are constantly putting on. It's a checks and balance system. So osteocytes are located between the lamellae in the lacuna. You remember lacuna? I've talked about that a lot, the little black holes they live in. Lacuna. Well, there's a lot of lacuna there. These are like burgundy lacuna here, and they look like little spiders, the little cells inside of them. So there's the osteocyte, and it lives inside its lacuna. So practice labeling. Periosteum is 1. 2 is the medullary cavity. 3, of course, is the compact bone, the outside part. 4 is the cancellous or spongy bone. 5 is it's an epiphyses on the end. It's a line, so it's a epiphyseal line or epiphyseal plate, your growth plate. 6 is the epiphyses. 12 is, well, 12 is supposed to be the osteon. I don't know what it's pointing at there. That's 7 is osteon. Good. Yeah, 7 is the osteon. I looked down to 12. 8 is perforating canal. Comes across against, we talked about that a couple slides ago. 9 is your endosteum, lining the inside of the bone. 10 is the canaliculi, little tiny canals which allow blood and nutrients to seep to and from the cells and the blood vessels in the central canal. 11 again is our osteocyte. And 13 is the diaphysis, the shaft. 12 would be the neck of the bone, but that's next unit, so we'll ignore that. Oh, 14 is lacuna. We forgot about little lacunae hidden down here. 14 is right next to the big number 9 in the labels. All right, so lamellae are the sheets put around. Canaliculi are the little cracks. There we go. Canaliculi are tiny little canals or channels running between the osteocytes and the blood vessels to bring them food and to take waste back from the cells to the blood system. There's canaliculi again. Okay, that's spelled wrong. It's actually canaliculi, like canal liculi. Somehow the owl came out of there. Owl left behind the can. Now we just have canaliculi. Anyway, that's messed up. Canaliculi. There you go. You can see a picture of a real, honest-to-goodness osteon and bone. They are pathways for nutrients. Wow, I said this again. That must be kind of important. They look like cracks in the lamellae, and waste products do diffuse through them, like I said a couple slides ago. All right, cancellous bone is our spongy bone. Again, the matrices that make this up, the scaffolding of hydroxyapatite, the way it's put in there, allows for greater strength, less weight, and allows storage of red bone marrow. Is spongy bone, located in the epiphyses of the long bone and the interior of other bones. This was also Gustave Eiffel, his inspiration for the design of the Eiffel Tower. If you look to the right here, you can see the scaffolding. He looked at that, thought, man, bones are strong and lightweight. That's where he got the inspiration for the scaffolding effect of the Eiffel Tower. Trabeculae. I say trabeculae with a French accent because that's what Gustave Eiffel, Eiffel Tower designer, looked at, the trabeculae. So if you say it like that, you remember, hey, a little history too. Gustave Eiffel took his inspiration from our bones. Probably chicken bones. There's trabeculae. Interconnecting rods or plates of bones. They provide extra, like I say, extra strength because they're hollow. So if you take physics, you understand tensile strength and how hollow round shapes are stronger than a solid round shape. The spaces are filled with marrow, mainly red marrow, which produces the blood. Consist of lamellae. Of course, lamellae are just the sheets put on, and the osteocytes trapped inside their lacuna. All right, a review, nice picture review. I like this. You can pause this and look at them all. It's all labeled for you. 6 bone features. No, now this is the last part of chapter 6, or the part what I call skeletal system part 1. So foramen is a hole in a bone. As much as I hate saying this, women like this. You say for a man, right? For a men. It's all men need another hole in their head, right? Our head's a bone. So women like to make fun of us, so they can here. One and only time, women. For a man, it's for a man. He needs another hole in his head. Mean, but maybe you remember it that way. Foramen. So a foramen is a hole. Example, foramen magnum, where your spinal cord goes through. Magnum means big. You know that. Hopefully you know that. Anyway, foramen literally means hole, big. It's a big hole in the bone. Fossa, Mufasa. Ooh, it's a depression. Remember, they were depressed when Mufasa died. So fossa is depression. You got to know your Lion King to make sense. A condyle is just a smooth, rounded end of a bone where it articulates with other bones. So here you can see a lateral condyle and a medial condyle. Medial, that means on the inside, lateral on the outside, or right, whatever your lateral side. You got your epicondyles, which we'll talk about later, not right now. So your condyles, smooth ends where they articulate. And of course, condyles are usually covered with hyaline cartilage. So it's a smooth movement there. As you get older, you bang your knee around playing a lot of basketball, volleyball, whatever, gymnastics especially, do a lot of damage on that. Then you get bone-to-bone contact. That's called osteoarthritis. A process is anything which protrudes. Protrusion, process. They both begin with pro. It's a projection from a bone. Here you can see at the very bottom of this picture, these are your rib cage, and there's your sternum. Sticking out the bottom of the sternum is this. Oops, the xiphoid process. There is a sternum. So yeah, the xiphoid process sticks down. When you do the Heimlich maneuver, you're supposed to roll a fist below that so you don't snap that. The tuberosity or tubercle is a bump. You know, tuberculosis, little bumps in the lungs. So a tubercle, a bump on a bone. Your tibial tuberosity is one of the ones which you can find easily. Reach down and pat your patella, your kneecap. Right below that, you feel a little bump. Well, that's where your anterior ligament there attaches to your tibial tuberosity and attaches up to the patella, keeps your patella bone stuck. So your patellar tendon is stuck to the tibial tuberosity. A canal or a meatus. So canal, what do you think a canal is? Very good. It's a tunnel or a canal through a bone. The external auditory meatus is external on the outside, auditory to hear with, meatus. It's a canal that goes from the outside to your brain. You have a little thin tympanic membrane called the eardrum that separates the outside from the inside. Good thing we have earwax, which is insecticidal, so insects can't chew through that. Otherwise, we'd die. Yay, Snoopy dancing. You know why? It's the end of the chapter. Study, study, study these notes every day. I'll put this link out on Remind for you through text. I'll put it on my website. Please study these every day.